Welcome to Investigation 3.2, Solving Linear Equations, or solving more linear equations, we really should say. In this investigation, we are going to be comparing costs. We're going to be looking at one linear equation and another one and sort of understanding what it means to potentially have those two equations be lines that cross and understanding what that intersection potentially would mean. So let's look at our situation. We have two tile companies. We have Cover and Surround It, where we have it's going to cost $1,000 for design and delivery, and then $25 per tile for after 12 tiles. And then we have Tile and Beyond, which costs $740 for design and delivery, but a higher per tile cost of $32 per tile after 10 tiles. So these can be modeled with these equations. We have C sub C, so that C is being shown as a second C for Cover and Surround It, is equal to 1,000 plus 25 times n minus 12 in parentheses. And then Tile and Beyond, which is C sub T in this case, which is equal to 740 plus 32 times n minus 10 in parentheses. So one thing that I'm hinting to here is this type of notation, C with a little t, is called C sub t. That's how you would say it. So if you had another one that was like B with a tiny p, you would say B sub p and sort of explain it like that. So that could be a different baseball company or something like that. So this idea of having two different equations with two different names, just knowing that C stands for the cost, and then the T's and the little c's and the little t's are essentially the name of the various companies is important. So let's move on from there. So we have these two equations. Without using a table or graph, find the number of tiles for which the two costs are equal. So we need to find when these two costs are equal. The reason why we shouldn't do it with a table or graph is because it'll be too obvious. I want to get you guys going to the place where you're looking at the equations and saying, I just can manipulate these equations, than having to graph something or create a table. And so what we're looking at is we would potentially have a graph where we would have 1,000 that goes up a little bit, and we might have 740 that goes up a little steeper. And this intersection is what we are looking for. If we had two tables for the two equations, we'd be looking for the place where the two values, or the x and the y value, or the n and the c value, in this case, the number of tiles versus the cost, ends up being the same for the two of them. But let's do this without using a table or a graph. So we have C sub C is equal to 1,000 plus 25 times n minus 12, just writing it down, and we have C sub T, which is equal to 740 plus 32 times n minus 10. Those are our two equations. Using these two equations, we need to find when the costs are equal. So that means C sub C needs to be equal to C sub T. Well, C sub C needs to be equal to C sub T. So we could essentially rewrite this as saying 1,000 plus 25 times n minus 12 is equal to 740 plus 32 times n minus 10. If I do that, I am finding when the cost for Cover and Surround It is equal to the cost of Tile and Beyond. So all I need to do now is actually do the math work that's involved here. I need to get n on one side, and I need to get all the numbers on the other side. If I were to do that, I will find where the costs are equal. So to start out with, let's do a little bit of math. Let's get rid of the parentheses. If I look at the inside of these parentheses, I see n minus 12. I can't do anything with that. I have two very different things that are being compared. I have the number of tiles minus something else. I don't know what the initial number of tiles are. But what I can do when I'm trying to get rid of parentheses is I can also look beyond those parentheses. I can look at this information. I have 25 times n minus 12. So the way that we can get rid of the parentheses, instead of doing the math inside of them, we can take some of the math into them. So we can take the math from the outside in. So we could write 1,000 plus 25 times n is 25n, and 25 times a negative 12, which is equal to 300, or negative 300. And that's all equal to 740 plus 32 times n minus 10. So we need to do a little bit of distributing here as well. So we get 740 plus 32 times n, or 32n, and then 32 times a negative 10, which is negative 320. Let's finish up this math work. Why don't we? We have a little bit of like terms that we can combine. We have 1,000 minus 300, so we can do that math. 1,000 minus 300 is 700. And then we still have plus 25n, and that is all equal to 740 minus 320, so we can do that math as well. We can say that is 420 plus 32n. And now we just need to get our n's on one side and all the numbers on the other. So I notice that I have 32n over here and 25n over on the left side, so I could subtract 25n from both sides. And the reason why I'm going to do that is that way it keeps the right side n's positive. So we'll end up with 7n is plus 420 is equal to 700. And now we're going to subtract 420, and then we'll divide by 7, because we're doing the opposite of what is there. So 700 minus 420 gets me 280, and that is equal to 7n. So now we're going to divide by 7 on both sides. So we get simply 40 is equal to the number of tiles. So when the number of tiles is equal to 40 tiles for either of the two companies, they cost the same amount. That is where this intersection happens. At that intersection, if we were to look at our table, or our graph, it would say 40 tiles, and then we'd have a certain price that they would cost. Kind of interesting. As well, it would be 40 tiles in our table. It would say the same thing, and we'd have that same dollar amount for our cost. So that's that point of intersection. So when n equals 40, how can we check that our solution is correct? So this is the next part. We have c sub c is equal to 1,000 plus 25 times n minus 12 as our original equation, and we have c sub t, which is equal to 740 plus 32 times n minus 10. The way we can check and see if our equation is correct is let's put n is equal to 40 into the equations. Okay? So I've done a little bit of magic and added those equations and done a little math work. We have that 1,000 plus 25 times 40 minus 20, or 12. So I've put in that 40 into our equation for the top one, and I get 1,000 plus 700 after I've done this math work right here, and I'll get 1,700 for my total. I also did it over here, so I see 740 plus 32 times 40 minus 10. I'm going to do the 40 minus 10 first. I get 30. 30 times 32 is 960. I'm going to add that to 740, and I'd also get $1,700. So we can see when the tiles are at 40, it costs the same amount. So that's how we can check that our equations are correct. We got it. Yay! N is equal to 40. Okay, so we need 40 tiles. Last little bit for this particular investigation. What are we looking for in a graph? That should be a graph, not no graph. In a graph or a table to determine when two companies and tiles and costs are the same. So we just talked about it. Our graph would have some sort of intersection. We would know at that intersection, we would say, all right, this is where that 40 tiles occurs, and this is how much it costs when that tile occurs, and that is essentially the same. That is essentially the same information for both scenarios. So one graph would be like that, and the other graph would be like that. As well, for tables, we'd have one table that said N and then money spent, and then the other one would also have that same table, and somewhere on one table would show 40 got me 1,700, and on another table we'd see that 40 got us 1,700. So we'd see that the same data is shown twice. For what number of tiles is cover and surround it cheaper? So when is C sub C less than C sub T? So we have our equation. C sub C is equal to 1,000 plus 25 times n minus 12, and tile and beyond is 740 plus 32 times n minus 10. And we need to figure out when cover and surround it is cheaper. So we know our turning point, our tipping point, happens at 40 tiles. At 40 tiles, both companies make $1,700. So one company prior to that point is going to be cheaper than another company. So how can we figure out which one it is? Well, let's try 30 tiles. So you're simply going to put 30 in for N for both of them, and you're going to determine which one is actually cheaper, which one's making less money or which one's making more money. And what we can see here after the math work has been done, that cover and surround it at 30 tiles costs more money than tile and beyond. And so because of that, we can say for what numbers of tiles is cover and surround it cheaper, and we can say simply cover and surround it is cheaper for 41 tiles or more. So essentially we can say that for less than 40 tiles, tile and beyond is cheaper, and beyond that, cover and surround it is cheaper than tile and beyond. So there is our statement that we can make. Use this video and any of this information that you saw in this video to help you through this investigation. This is part 1, noticed, part 1 of Investigation 3.2 videos. Excuse me. If you want to watch another video, we have Investigation 3.2 Part 2, and that deals with Part C, I believe, of the investigation. So hang in there, watch that second video if you need it, but go ahead and start working on 3.2, and as always, please make sure you ask any questions if you have any. Thanks so much. Bye.